Hello boys and girls, so in this video we are going to continue our discussions on Learning Outcome 3.5, Resistor in Series and Parallel, and Learning Outcome 3.7, Electrical Energy and Power. So, basically resistor we might connect it in series and also parallel. Do you still remember how we distinguish between series and also parallel connections as we discussed in capacitors? We said that if series, we only have one lead connected. If parallel, we have two lead connected. I hope you still remember this one. If parallel, we have two lead connected. Let us recall. So, this is our first resistor. Then we have the second resistor, R2. We have the third resistor, R3. So class, if you notice, we only have one lead joined together. See, R1 and R2 is only joined together at one of their leads. Another lead of R1 is connected to the battery. R2, another lead of R2 is connected to R3. So, this one we call it as series. Satu kaki je dia disambungkan bersama. Okay, so this one is series. What about parallel? The resistor will have two lead connected. So both lead of the resistor is connected together. That one we call parallel. See, we have this one. This is our first resistor, R1. Our second resistor, R2. Our third resistor, R3. So, you can see very obviously, all their lead here are connected and another side of their lead also connected. So, they have two lead connected together. So, this one we call it as parallel. So, I hope you can distinguish series and parallel. Alright? Okay. So, how we are going to find the effective resistance, or we call total resistance? If the resistor is connected in series, the effective resistance is given by R1 plus R2 plus R3. Then for the parallel combinations, in order to find the effective resistance, we are going to have 1 over R effective equal to 1 over R1 plus 1 over R2 plus 1 over R3. Then class, we have to remember for the series combinations, the potential difference or the voltage across each resistor will be different. So the voltage V that we supply will be V1 plus V2 plus V3. So the voltage is add for series combinations. And for parallel combinations, the voltage is the same for all the resistors. So the voltage across resistor 1, V1 will be equal to V2 will be equal to V3. Okay, what about the current that flow through each resistor? So, for series combinations, there are only one path. There are only one path for the current to flow. So, the current will be the same for R1, R2, and R3. But for the parallel combination, class, you can see very obviously, the current, when it reaches point A, it will be divided into three different paths. So, the first path we are going to have I1, second path we have I2, third path we have I3. So, the current will be added for the parallel combination whereby I1 plus I2 plus I3 will equal to the current that flow out from the battery. Alright, so this is the main concept we are going to apply when we want to solve question for resistor connected in series or parallel or the combination of both of it. Then class, for any resistor that we connect in a circuit, there will be voltage drop across it. Okay, and this voltage drop will cause it to dissipate electrical power. So how we find the electrical power dissipate by a resistor? So the power will be equal to the current that flow through the resistor, multiplied with the voltage. And then class, if you still remember from Ohm's law, V equal to IR. So I put it in, I'm going to have I squared R. Alright, if I substitute V with IR, I'll get I squared R. Okay, beside that, I might also have I squared R. I is what? V over R. When we rearrange from Ohm's law, so I is V over R squared multiplied R. So one of the R will be cancelled. So I'll get this one, V squared over R. So we are going to have three equations that we can use to calculate the power that dissipates through a resistor. Which one we want to use? It depends on the information given, whether you know about the current, voltage or resistor. So what is the SI unit for power? So SI unit for power is watt. Then class, the power actually we can relate with the energy. Normally this electrical power is converted into heat energy. So you will find out that the resistor will get heat up. It will become warm. Dia akan jadi panas. So the energy dissipated through the resistor will be given by, how we get this one? So we have power is energy over time. So energy will be power multiplied time. So power is IV. Power is IV from the above equation. Power is IV. So we have energy will be IVT. Or we have power is I squared R. So I might also have energy is I squared R multiplied time. Okay. So what is the unit for energy? The unit for energy is joule. So this is how we find the energy and also the electrical power in a resistor. Okay, so now let us move on one example, how we are going to apply the concept we just discussed just now. Okay, so I give you a circuit. I have three resistors, 4 ohm, 12 ohm, 2 ohm, connected to a battery, 8 volts. So I want to find the effective resistance. So I want to find the effective resistance of the circuit, the current that passing through the 12 ohm resistor, the potential difference, or we refer as the voltage drop across the 4 ohm resistor, and also the power that delivered by the battery. So the question said the internal resistance of the battery might be ignored. So I have three resistors, so I label the resistor. 4 ohm I label as R1, 12 ohm I label as R2, 2 ohm I label as R3. So how I'm going to find the effective resistance? So I'm going to simplify the circuit. I'm going to simplify these three resistors into a single resistor. Okay, so each time when we simplify it, we redraw the circuit. So how I'm going to know the resistor is connected in series or parallel? So remember, you checking whether it's only one leg connected or both leg is connected. So class, if you refer to my drawing, you will find out that for resistor R1, in between R1 and R2, is only one lead is connected here. So it's only one leg connected. So R1 and R2 are in series. Okay, what about R3? You will find out that one leg of R3 is connected to R1, another leg is connected to here. So it means that R3 is in parallel with both resistor R1 and also R2. So I can redraw like this one now. So R3 is in parallel with the combination of R1 and R2. Finally, I have simplified it into one effective resistance. So now I can start to calculate the total resistance or the effective resistance. So since R1 and R2 are in series, so I apply the concept in series. So the R12 will be 4 plus 12, 16 ohm. And then the combination of resistance 1, 2 will be in parallel with R3. So I have 1 over R effective is 1 over R12 plus 1 over R3. So I'm going to have 1 over 16 plus 1 over 2. So I'll get the effective resistance is 1.78 ohm. We have done with question A. Then question B, we want to find the current that passing through 12 ohm resistor. So how I'm going to find the current that passing through 12 ohm resistor? So I want to find the current that passing through R2. So I label it as I2. So R1 and R2 is connected in series. So you understood? The current I1 will be equal to current I2 will be equal to the current 12 because R12 is connected in series. Then R12 and R3 is connected in parallel. So for parallel combinations, you will find out that V3 will equal to V12. Then this value will equal to the voltage that we supply. Okay, so equal to 8 volt. Clear? So I'm going to use this one. I can calculate the current. So I can see obviously from the circuit, my voltage across resistor 3 and resistor 12 is 8 volt because they are in parallel combination. So I have this one. Since R12 and R3 are in parallel, so voltage across 12 will be equal to the voltage across third resistor or equal to 8 volt. So then from this one, I can calculate the current. Current that pass through R2, I2 will be V12 over R12. So voltage across the combination of resistor 1 and 2 is 8 volt. The resistance combination of 1 and 2 is 16. So I can get the current is 0.5 ampere. Why I might say that the current that pass through 1, 2 is equal to I1 equal to I2 because resistor 1 and resistor 2 is connected in series. Kan dia sambung secara series. You perhatikan balik gambar ni. Current yang lalu dua resistor 1 dengan 2 ni adalah sama sebab dia sambung secara series. Okay. Then the third question, we want to find the voltage across resistor R1 across the 4 ohm resistor. So where is for 4 ohm resistor? This is your 4 ohm resistor. So class, you will notice that you already get the current. The current that flow through resistor 1 and resistor 2 is the same. The value you already calculate is 0.5. So the current is 0.5 ampere. But R1 and R2 is connected in parallel. R1 and R2 is connected in series. So the voltage will be different. The voltage across R1 will be V1. The voltage across R2 will be V2. And then we can see obviously for series combinations, V1 plus V2 will equal to 8 volt, the voltage that we supply. Alright, so we have this one. So I know that current I1 equal to I2 equal to 0.5. So I know the current that passed through the 4 ohm resistor. Now I might calculate the voltage across the 4 ohm resistor lah. So V equal to IR. So since I want to find the voltage across the first resistor, 4 ohm resistor, so the current will be the current that flow through 0.5. The resistance is 4. So I'll get the V1 is 2 volt. Okay, now we want to find the power delivered by the battery. So the power is V squared over R. Why I choose this one? Because I know the total voltage that's supplied by the battery. So the voltage that's supplied to the battery will be given to all the 3 resistors. So remember, so you are going to have effective resistance here. So the voltage of the battery is 8 volt over the total resistance in the circuit is 1.78. So I'll get my power delivered by the battery is 36.0 watts. So this is how we apply the concept to solve the questions.